Microphone check. Okay, it works. Nice. What's up, everybody? Let me update my title real quick. Hang on. Check 1, 2. Yeah. Excellent. How's everybody doing today? Zoom in on my LaCroix. Yeah, I got that from Rudder. He gave me the idea. Credit where credit's due. I am wiped today. We may just do 2 hours. We'll see. Last night I was on call until 6, and of course at 5:58 I got paged out. Somebody's site was broken, except they'd never tested it, and they were going live right then. And then, so I was like stuck till like 8 p.m. on the computer. One of the few times that's happened, but yeah. After that, I got mad and bought a bottle of Evan Williams and went ham on it. See what I did there? So yeah, we're a little bit peaked today, but we have lots of cool things to look at, lots of toys and stuff like that. So let's just dive right in. To remind everybody of the context, I'm going to be building a controller for my satellite antennas that's going to spin things around and point them in a certain direction. Either I'm going to put it the bearings in manually with little knobs, or it's going to be automatically computer controlled. So I ordered a whole shitload of stuff over the past week or so. The mailman's been very heavy on the blessings. So I got almost everything in. There's a couple parts left that I'm going to need. And I need to buy a box too. I'm not sure what box I'm going to put this gadget in. So let's take a look at some of the stuff I got. Camera down here would be good. Check out the fucked up, chipped up bench. I think I'm going to get a new desk because I've worn this thing down a whole lot. Let's see. We have Arduino Unos, or clones thereof. And that was a big old fail. Hang on. Where's my knife? One of my many. You can see why it's messed up. I just use it for a cutting board. Yeah. Got some clone boards. Who's laughing now? They're like $5 a piece. Not too bad. Just your standard Uno design. We got about, I want to say like 22, 24 I/O pins, something like that. So should be sufficient for the project. I've actually taken a look at the sketch for the rotator controller because somebody else wrote it, and it does fill this up pretty heavily. So I do have an old blown out Mega. It's kind of dirty. I need to pick it up or like clean it up, but it works, and it has like 9 million I/O ports and a little bit more beef. Might use that. Let's see, what else did we get? Got a whole bunch of pot in the mail. 10K potentiometers. Very nice. Nice smooth action. Comes with knobs and all the hardware. That's pretty cool. Yeah, it might be a pun-filled day. We'll see. Some switches. These are just on-off switches, just for like functions that you want to leave permanently on or off. Let's see what else. These are different switches. Let's go ahead and crack these open. Oh, I already did. These are nice because they're momentary on. So by default they're off, and then you can go like that and go like that, and it'll connect one of the 2 pins on the outside to the center. So that's nice if I want to do like a up-down type, thing where I just want to hold the switch down to rotate the antenna up or down or left or right. Might use that, but I also got, because I've never messed with these before, They're really cool. Rotary encoders. So these are knobs that turn, and they have little clicky stops on them. Comes with knobs and stuff, and these are digital controls. So the 3 outputs here will go low or high depending on which way you're changing the value each click, and you can use a little library to kind of read that. And that way you have like an endless control. Like these can turn like around and around and around forever. So I got some rotary encoders. I may use those instead for my like bearing and elevation control. That might be pretty cool. Haven't messed with them before, so we got to play with software and figure it out. But I hear they're pretty easy to use. Let's see, what else did we get? So I've got that extra Arduino Uno. Arduino Uno. It just sounds dorky. Anyways, I also have my little test code project here. We're going to look at this in just a little bit. I have kept the plastic on. We're going to peel it off in real time if you're into that sort of thing. And hooked up the little magnetometer board and the accelerometer, and it works, and it's really cool. What's up, Trash Baby? Good to see you. Whoop. Let's see, what else do I have? I got these little boards, which are really cool. So all this stuff talks with a little serial protocol called I2C. It just uses 2 wires, power and ground. However, it has a max distance of like 10 feet or something like that. Beyond that, noise kind of pollutes the signal and causes problems. So I got these little things, and they're called differential transceivers. Yeah, differential transceivers. So I can hook like any part of this up to one of these, and then hook this up to the board, and then just use an ordinary boring Cat5 cable. I got a 1-foot tester here for just test purposes, but it'll go up to 100 feet. So that's what we're going to use to take this little board, which is going to be mounted on top of my antennas, and transmit the serial signals back from it, and be able to read it when it's up there on the pole out in the cold. Let's see, what else did I get? Pretty jumper wires of all sorts. Male to female, male to male, and female to female, so you can choose your gender here. Dug this out of the trash. We may just goof with this for a little experimentation. Not out of the trash, but out of my junk box. This is a 8x8, just a LED matrix. It's just red LEDs, but you can draw stuff on them, write on them, and stuff like that. They're really fun. Just a neat little display. Let's see, what else? Oh, I got the big power transformer for it. It's currently up on another shelf, but just a big, nice 24-volt transformer. Yeah, so we have lots of toys. So I'm gonna go ahead and switch over, and we'll bring up the screen, and then I'm gonna just start playing around with code. I'm gonna start out and do a. I grab my USB cable here. Start out, and we're gonna get to this in just a little bit, but I want to show some people the basics. Ooh, yeah, I could do the Twitch logo, huh? I wonder if I can find a nice RGB one that'll do the correct purple. So these are loaded by default with pull it back, see if focus will freak out a little bit less. These are loaded with the blinky LED program by default from the factory, so you can kind of just make sure that it works. Yeah, now that that's hooked up, organize my wires because I have too many of them. Let's see here. Switch screens over. Oh no, my porn. So this is the sketch. Sketch is like the code file that you load onto these. That's the terminology in this world. This is the sketch that I have for my little accelerometer test thing. I'm going to save this off and we'll come back to that in a little bit. Yeah, it's all C with some wrappers. Some of the libraries use C++, but this is pretty much just straight C. So if you know C, I know some of you in here do, you can write this stuff pretty flawlessly. Let's see, basics. Cool. So this is the Blink program, and I adjust the font on here. Oh my god, shut up, TweetDeck. Hang on. Got too much social engagement going on. So here is the stock loaded Blink program. Like I said, it's already on there from the factory, but this is what it looks like. Bunch of comments up top. Somebody's been working on this. They haven't touched it in 2 years. You got to keep the Blink program updated, right? But this is what it does. In every program, you have some space at the top. You can do like declarations and includes here, and then you have a void setup function. The setup function or sub does it runs exactly once at startup, and then how these things work is they just have a loop block, and it just loops forever. So it's up to you to get everything inside there. You can add other functions outside of it and call them, but you have to have a loop function. Sometimes it's blank. Like if you just want to like do something at startup and do it once, you can just put it all in setup and then just have an empty loop, but you have to have it there. So this is what the code looks like. Oh, that's hilarious, Radar. Yeah, I don't know. It might be. I'll have to take a look at it. So there's some built-ins to basically allow you to easily address all of the different pins on here. You can access the registers directly, like for the digital IOs. There's just 8 different bits you can set at a particular address and turn them on and off, and it's a little bit faster than calling the digital write and digital read and stuff like that. But you have to know what you're doing and stuff like that. So it's easier when you're starting out, probably for the first couple months, just to use the built-ins like digital write and delay and stuff like that. So what this does is this turns the LED on, waits 1,000 milliseconds, turns the LED off, waits 1,000 milliseconds. So let's mess with it. And let's have it on for 300 milliseconds and off for 100. That looks pretty good. You can just click the arrow to like compile and upload, or you can make sure that it'll compile first before you try to shove it on there. Cool. No errors. Yay. Down here, it shows how much memory you're going to have. You set which unit you're uploading stuff to over here. And then it knows how much program and how much variable RAM is in there. These are Harvard architecture, which means that program and addressable memory is separate. So like they can't have self-modifying code basically. So this is going to use 950 bytes out of 32K. That's the program memory. And then we're using 9 bytes. I don't even know why we are using variable memory. I guess maybe one of these will take up a couple bytes. But we're using 9 bytes of dynamic memory out of 2K. So these are teeny tiny. Yeah, I was wondering if the font's a little small. Let me see if I can. Yeah, I sure can. Hotkeys don't work. So yeah, down here the errors evidently fixed size, but yeah, 32K program and then 2K for variables. So It has compiled. Let's do it again, just because. Waste electricity. And then let's upload it. Problem uploading to board. Oh, I wonder if it's on a different serial port. Yeah. Because I was using the other one, and the way the serial ports work on these is they actually have a USB to serial bridge on here. It's that little chip right there. And so they'll show up as different serial ports for different units, because Windows is stupid like that. So let's pick COM6, and then we'll upload. Oop. Now you can see that we're on for 300 milliseconds and off for 100. The timer's fairly accurate on these. I've measured the clock rate of a lot of these. More font. I'll zoom this shit in. I don't care. Sadly, I can't change the error stuff at the bottom, or the status, but that'll maybe be a little bit better. There we go. Now we're looking. Is that a little more readable? Those of you with old bad eyes. It's a terrible font, too. Anyways. Cool. So we have successfully customized our Blink program. Yeah, so that's the very basics of how you compile and upload a program. Let's see what else they have on the examples. Ooh, let's try fade. Fade's pretty cool. No, I don't want to save my Blink changes. All right, so for this one, I'm not sure if it can use the built-in one. I think the built-in one is just on and off. So what I'm gonna do, let me dig around, and I'm gonna find a breadboard. We're gonna hook up an LED and a pin, and we'll actually get some circuitry going. One sec. Got a little breadboard. And let's see here. I'm gonna use a nice red LED for this. It's my favorite color. All right. And then one cool thing about Arduinos is that they have built-in current limiting resistors. So you can just hook an LED straight up to the board. You don't have to have a resistor. Normally you do, or else the LED will burn out. Whoops, dropped one. The longer terminal is positive. That's the one we're going to be driving. And then the bottom one is ground. So, how a breadboard works, you have a couple of rows up here and down here. These are all connected left to right. So you can use those for like negative and positive buses, just for voltage and ground and stuff. And then in the middle, there's 5 columns here. It's split in the middle, and then each column is connected. So you can hook up different parts by using multiple rows in the same column, and they'll be connected inside it. So let's take our LED. Remind myself which one. Okay, that's positive. The longer one is plus, so. Just take it and find a couple spots there. Alright, so now we need 2 jumpers to hook this up. Bought a whole crap load. And we're going to need a ground pin, so we find ground on here. It's got a couple of them, and that goes to the shorter side of the LED. And you just plug it into a different column on the same row. Not too bad. And then the fade program uses pin 9. So let's find pin 9. I believe it's this one here. And then that gets hooked up to the other side with the LED. All right. And now I think... All right. Compile. Looks good. Oh, the font did change size there. Maybe when you open a new program. This is not the best IDE. I've actually seen people use like frickin' Eclipse for this stuff, which is kind of cool. So let's go ahead and upload it. We're overwriting the old program. There we go. We have a nice fading LED. It's kind of hard to see because it kind of maxes out on the camera brightness, but it's definitely doing a nice fade there. Awesome. So you know, take a look at the code and hack on a little bit. Let's see here. Pin 9, how bright the LED is. Oh, that's just the initial. That's the initial value. And the fade amount. Okay, so it changes the brightness of it by it can go from 0 to 255, and it changes it 5 at a time. So there's like 50 steps. So yeah, it takes about a second and a half ballpark. So let's change this to 2, and we're going to make it fade more slowly and smoothly. Oh yeah, that camera's freaking out. It is not happy. Yeah, very slow. All right. And actually, I'm going to turn the max brightness down here. We're going to max it out at 100 because I think it's just kind of blasting out on the camera. Yeah, get shades. Yeah. It's definitely a lower max brightness now. But the cycle's also faster now because we're changing by a fixed amount each time. Let's see if I have anything. I don't have any sunglasses. I don't wear sunglasses. So I don't have any like smoked plastic or anything. So anyways, though the camera's kind of doing shitty things to it, it's definitely doing a nice little PWM fade. So that stands for pulse width modulation, if you're not familiar. And what that means is that the positive line of this wire here is not actually changing voltage. It's only going 0 and 5 volts. What it's doing basically is turning on and off very quickly, and the amount that it's turned on for each little short cycle, it does it at like 15 kilohertz. But the time that it's on for each cycle changes when you change the analog right here. So you can write a number from 0 to 255. 0 means it's never on. You set it to like 10, and it just turns on for a little bit each time, but it's doing it 15,000 times a second, so you don't see it. It's way faster than your eyes. And then at 255, it's basically on constantly. So PWM is very important to understand when you're controlling things in an analog fashion with these, because you're not actually wiggling a voltage up and down. You are just turning it on and off really fast and changing how long you leave the light switch on each cycle, basically. So yeah, it does have analog input though. So these, yeah, let's see if they have an example sketch. Analog input. Okay. Demonstrates analog input by reading a sensor on pin 0 and then turning an LED on and off with pin 13. Cool. So let's build this up. So we're going to keep our LED here, but this is on pin 13 now. So I'm going to just change the wire. Put it over on 13. All right. Yeah, that's a good idea. One of the things I'm going to do is I just finished redrawing my logo in Illustrator, so it's a vector drawing, and I can send that off to a laser cutter place. And we're going to make a sign with my logo back behind me up in the big black window, and it's going to have RGB backlighting, so it's going to have kind of a glow around it. And I'm going to have a little Twitch command, a little slash command, so that people can change the color whenever they like. So that should be fun. Let's see. Okay, so what are we doing here? We need one of our pots. Some dank pot here. Hopefully these will fit into the spots on the board here. They're not really meant for like insertion. Yeah, that'll work. Cool. All right. So we need some more wires. We need one to go. We're still using ground here, and we're going to need it for this control as well as for the LED. And that goes to one of the 1, 2, 3, 4, 5. There's 3 pins on this control, but it skips pins because they're spaced 0.200 apart instead of the 0.100 of these. So let's see. I had some prescription sunglasses and they were freaking dope, and then I got old. Prescription went way out of the whack, and then I had to get new glasses when I was working for a shitty weed dump, and I didn't even have vision. Okay, so we've got one side of the control set to ground. We're going to strap the other to plus 5 volts, and fortunately there's a pin handily available there. Cool. 0 and 5, and then what else do they say here? The center pin goes to analog input 0, which is, I'll get a longer wire for that. Use a nice red to keep it separate. Plug that into the 3rd row. So now we have things hooked up to all 3 terminals of the control. And then analog 0. Nice. Okay, so make sure it compiles. Let's upload and let's see what this sketch does. Okay, so it's blinking. Let's try adjusting this. Well, I turned it down and it went slower. A little faster, about halfway. And then it's on solid when I turn it all the way up, which is what the sketch does, yeah. Yay! We have a controllable blinky light. So there's kind of a like running joke of people that use like microcontrollers to blink an LED. And I used to be one of the people that were like, just use a 555 timer and a couple of resistors and a capacitor if all you're doing is blinking a fucking LED. But here's why I've changed my tune on that, because this board, which is like $5, and there are smaller versions that run as low as like $1.79 for the full board. As soon as you want to do anything besides just blink the LED at a static rate, you're automatically ahead with this. Because this can do weird things like read inputs and control how fast you're blinking the LED. So I'm turning that control and changing the rate of it. And that's like a big advantage. You can of course do this with a pure analog circuit. I've got a stack of 555 timers there. We'll get into analog ICs and stuff probably a little bit down the road. But for now, like, I like just messing with these because I can just write code and have it do dumb shit. And it's a whole bunch of fun. Customize, and then you just start to think up weird ideas and kind of, make a bong out of it. As you all know, I'm pretty good at. You just write code and you kind of crank it out, and then you can have your little project do whatever you want, and then create multiple ones. If you have the wiring nailed down, you can just get 10 of these boards and like mass produce blinky LED circuits. Without dealing with any like inconsistencies in parts, say your capacitors are different values or something. Doesn't matter because it's all software controlled. So I like this approach a lot more for doing any sort of just experimentation and fun. So yeah. Let's go through a couple more. Let's see what other stuff we have. They have lots of sample programs that they include. Just lots of like programming tutorials too. How to use arrays, how to use for loops, conditionals and stuff. So they'll teach you C basically. So if you want to get good at these and then go get a job writing C, you'll be in really good shape. Oh yeah, these things can emulate a USB keyboard. So you can just type dumb shit via this thing. You don't have to have buttons set up. You just plug it in and it starts typing, whatever, Navy SEAL copypasta in a box. You just hook it up to like any computer and it just types it out for you. You can totally do something like that. As a matter of fact, can we do that? I want to see if this works. All right, let's goof with this. All right, we're going to shut this down. And then I want to make a fake keyboard. So we take off the +5 and the ground, then analog and the LED. All right. So next stupid trick. So what do we need to do here? We need a push button. Do I have a push button? I do, but I don't know if these are going to hook up to the breadboard, but that's okay. Nice little, there you go. Awesome, that'll work. What I'm going to do here, because I have 9 bajillion of these test leads, turn the soldering iron on, and then zoom out a little bit. Take a sip of my LaCroix. It really is LaCroix, by the way. I know you want to pronounce it in the accurate French pronunciation, but it comes from LaCroix, Wisconsin, so I respect their pronunciation when I'm actually talking about it. Yeah, we can use one of those momentary toggles for sure. We could actually have it do 2 different phrases if we go left or right. Heck yeah. I got a 20x4 display here that we're going to take a look at in just a little bit. Very nice. I'm glad you got your stuff in. I hope you're having fun. If anybody's curious about getting into this, we'll have a little bit of a time of discussion of what you need as kind of a basic little supply to get started. So I'm going to just solder 2 of these jumper wires to the switch contacts. There's one. Move my mic just a little bit. Oh, yeah, thank you. Really bad at looking at the screen. I'm trying to remember. And there's 2 wires. Groovy. Okay. So let's see what we can do with this here. Take all of our stuff off the breadboard and start anew. Turn off the soldering iron because I don't think I need it for anything else. Alright, let's see if we can get this working. So, and actually, we don't even need a breadboard for this. We can just plug this in. So we're going to want to hook this switch up to number 4 on here. What's up, Defense? How's it going? Thanks for joining us today. And then we hook the other side of the switch to ground. So these normally sit at plus 5 volts. So they have a little, what's called a pull-up resistor. And then when we hit the button, it's going to go to 0 volts. And that's how we're going to tell if it's low or high, I believe. So let's get us some copypasta. And we're going to just use that last line because that adds a carriage return at the end. All right. So let's see if this thing works here. Check it. Make sure it's not crying. Does it include keyboard.h? Yes. Let's see if this compiles. All right. Let's undo our joke thing here. Keyboard not found. Huh. This is where it gets frustrating. Let's see if it tolerates that. Yes, I certainly did include that. Is it lowercase? Shouldn't be. Well, that's really strange. What do you think might be going on here? I'm having to look through my camera. Sorry, it kind of sucks. Let me revert back to the... Where was that? Yeah. that's not it. Keyboard message is what we want. Yeah. Kind of shitty that they don't have all the necessary libraries included with the sample programs. Let's see. Do I have to download it? Oh, because it's not supported on this particular board. They can't fake USB HID devices. Okay, on to a different project. That explains it. Sorry, keyboard message, we can't make a shitpost bot. So sad. Glad I looked that up though, yeah. I don't have any of the like new gen ones. I have old school boards here. Because I know them a little bit better. Let's see, what else? Interesting stuff do we... I'm just trying to think of some stuff to kind of demonstrate some of the basic stuff. And then after the break at the top of the hour, we'll take a look at my little accelerometer project, because that is working. I've been playing with it all morning. Man, they have all kinds of cool shit in here. So yeah, these do have an EEPROM on them, which is neat. Just like a few bytes of storage that it persists after power is off. So say you're trying to keep track of some data over time, but you don't want to code it into the program. You want to be able to change it while the program is running, and then when it powers off and then back on, to be able to get that data back. It has like, I'm not sure how many bytes, just a few bytes, but you can save a little bit of data off, say like the current state of a knob or something like that, so everything doesn't reset from the like code defaults, every time you power it on. What other neat stuff? Basics. Let's see. Read analog voltage. We're going to just dive into my other project, because we've kind of taken a look at the basics, and so sad my keyboard button. I'm going to get a board just so I can do that, though, so I'm going to be able to have a thing. Wouldn't it be cool to have a little box that like has different like copypasta in it, and you can just plug it into something and then select with a knob which one you want to spam and then just shit it out? I think I'm going to build that in the future. That'd be a lot of fun. So let's shut this one down. I'm just powering via USB. Yeah, turn your monitor on command. That would be pretty sweet. Keep my wires clear here. They multiply very quickly. Very, very, very quickly. So, this project is the start of our rotator controller. I don't have the actual end code on it. This is just a test sketch. But we're gonna take a look at this. Let me pull the code up for that too. We'll take a look at it. There we go. All right. So I do have a little bit of the copypasta for a startup screen just to make sure that the LCD works. There we go. All right, so we have another Arduino, just another Uno. We got a 20x4 LCD, and then we have an accelerometer. This is a tiny board that has right in the middle a little chip. It's called the LSM303. It's an accelerometer, which means that it can sense forces and acceleration, and it's also a magnetometer, so it can act as a compass. And I have both of those functions working. So without further delay, let's go ahead. Hopefully all my jumpers are still securely plugged in. And try to get There we go. Yeah, so I'm going to have to kind of run the camera weird on this. But the interesting thing is, okay, so as I turn it, you can see the heading change. So that's compass bearing. And then if I just leave it on the desk, actually fix that, and then just put a little clip on here to just kind of weight it down just a little bit. There we go. So here's science in action. You'll notice that there's a little bit of acceleration in the X and the Y. That's because it's not perfectly flat right now. But the Z is sitting at right around 9.8. And this outputs acceleration values in meters per second squared. So if you remember your 10th grade physics class, the force of gravity is 9.8 meters per second squared. So if I take the board, and it doesn't like that, if I take the board and say I tilt it up, and you'll see it's now around 9.8 on the x-axis. And then if I tilt it like this, it's now on the y-axis. So this chip on here, and I'm going to try to show, I mean, that's the size of the chip. It's extremely tiny. It's got basically a little tiny weight in the middle of it. This is like a partially mechanical device. It's got a little bit of weight in it, and that presses on different kind of dielectric elements in all three dimensions around it. So it's like a ball in a little box. And depending on which way this is oriented, it's going to push on the X, Y, or Z sides of that more or less. And then the chip does some measurement of how much force is being applied to the X, Y, and Z axes by that tiny little ball in there. And it's like seriously like the size of a grain of sand. And then if it, like, because we know that gravity is always straight down, it just does, like, you can do a little bit of math and just like, it's like an arctangent function or something like that, and combine all the vectors and figure out the exact orientation of this in space and like which way is up, basically. And then the compass is it's on the same chip. Incredible, like, yeah, you can absolutely just like hook this up to your head and then use it as inputs for a camera pan for like a render engine, and it'll track your head. And a lot of people use them for that. But it's got the magnetometer in there too, and that has two, again, microscopic little tiny coils of wire at right angles to one another. And those measure the Earth's magnetic field. It's like 20 to 60 microteslas or something like that. Very, very weak magnetic field. I'm amazed it actually works here inside the house, because I live in an all-metal house. Yeah, the keyboard include, that's because we are using a little cheap $5 board instead of one of the newer gen ones that can act as a USB HID. So sad. But yeah, so the magnetometer, you just, I mean, I'll show you some of the code for it. So to start out, we include a couple libraries, and create the objects for the magnetometer and the accelerometer, so you can address them independently. You actually have to. Then we set up our LCD. This just tells it what the address is on that little serial bus, because you can daisy chain a bunch of devices on the same bus, and then they can just have different addresses. It's kind of nice. And then what pins on the Arduino are actually driving that. So we start up the accelerometer, we start up the LCD, and that's even before we do the void setup thing. I've just been kind of putting like slowly piecing this together, so it's not clean code. Please don't like, run me up the flagpole because my shit's sloppy. I know it is. But this is how you just write to an LCD. You have to tell it to start up first. That would be really cool, CFS. Yes, I like that idea. And Gosh, I want to do that now. I was thinking about doing like a tiny, well, like the tiniest little Pong game on one too. See if I can figure out how to get that working. That would be really fun. Um, Especially if I made two controllers on like little wire tethers with the rotary encoders for your Pong paddles. Could totally do that. That'd be fun. Damn. See, dumb ideas just flow out of these things once you start to goof off. Especially, you know, when I have like such a great crowd of people kind of watching and just throwing stuff out there. Things that I never would have thought of. So it's really nice to kind of have more people just kind of popping in and helping me out with ideas and all that. So going through the compass and mag code here, I just do a little joke startup thing for 1 second when we turn it on, and then this will actually send stuff out to the serial debug console, actually on the computer that it's hooked up to, if one's hooked up. So you can like do various dumps to here and check on things if you don't have a display hooked up, for example. And then we're still in the like setup block. We turn the magnetometer on. Hopefully, if it fails, it'll just basically shit out. Turn the accelerometer on. Again, fail if it doesn't work. And then in the loop, basically we get these lines here, get the current value of the little two coils in the magnetometer. And then the heading, here's the math to figure out what heading you're on. It does arctan of the X and Y axes of the magnetometer. And then looks like it's in radians. Yeah, so that'll output it in radians, and then this translates it to degrees to a float. Since we don't want negative numbers, which this can do, we just make sure that everything's a positive number. And then here I've added a couple lines. This adjusts for the magnetic declination here in Denver, because as you may know, the magnetic North Pole is not at the physical North Pole. Here we are 8 degrees off, almost exactly. So when a compass reads 8 degrees, you're actually looking straight north as far as like the globe is. So we just subtract 8 degrees from whatever the mag math comes out to, and that's actually where we're looking that would line up on a map. So yeah, we got our heading here from the magnetometer, and then we go on to pretty much the same thing with the accelerometer. This works in 3 dimensions though. I've commented out their serial debug thing here and just added it to the screen. So you can see we cleared, after this, we've gotten all of our input data, so we can just draw the screen here. So we do a clear, and then you have to manually set the cursor to wherever you want to type each line. And that's all that does, basically. Prints out the heading, and then prints out the accelerometer values here for the three axes, and then it delays 100 milliseconds and goes back up to the top of loop and starts all over again and just runs forever. So yeah, that's how the code works for this. That's all that's involved. Yeah, you can absolutely do that. If you know where the North Pole is, you would be able to figure out how much declination you need for a particular thing. I just Googled it and found a map where you can just click on any spot and they give you the current values. It does change over time. The North Pole wanders. Sometimes secondary, weaker North Poles form elsewhere up in the Arctic. Earth's magnetic field is not even close to like accurate and static. It changes like every year and moves around. I guess depending on like which way like our iron core is currently oriented or something like that. Yeah, it's not stable, and we've gone a long time without a pole flip. And that can happen too. North becomes south and south becomes north. And yeah, have the North Poles fight. That'd be really funny. And yeah, I'm sure that they have predictions as to the relative chance of each pole becoming the dominant one, stuff like that, or does it get stronger and weaker and stuff like that? Because GPS, of course, is a great boon for navigation, but sometimes you just want to use an old school freaking compass. So they keep track of that stuff, especially in the military and science world. What's the correction factor for this particular location and stuff? And of course, like up in like Yukon territory and stuff like that, and far north of Canada, your compass will actually will appear to be displaying north when you're looking like straight east, because there's so much declination up there. Yeah, it would take a fair bit of data, but fortunately, a lot of these devices have a lot more storage than this. You could also figure out some sort of basic compression or something like that, deduplication. I don't know. If you could figure out an equation, like a math equation, to like look at your latitude and longitude and know the declination from there, that would be probably the best approach. And I'm sure that somebody could just figure out like a multivariable, like a polynomial or something like that equation to figure out what the declination is for a particular latitude and longitude. And at least, eyeball it. I mean, we're talking about the difference of like, I want to say like 100 miles is like half a degree of declination change or something like that around here, but it changes with your latitude too. So the farther away you are from the North Pole, the less it wiggles. So, okay, we are at the top of the hour. Time for my customary break. We'll see what we're gonna mess around with here in a little bit. If you have any ideas for any dumb shit we can do with these boards, I'm taking all suggestions. But until then, I'm gonna take 5 minutes, and we will be right back. Alright, we returneth. Thanks everybody for hanging out with me. Probably am just going to make it a 2-hour thing because I need a nap. But I figured, as a little diversion, a little intermission, we'll just let this kind of tell us which way is north off on the side. I wanted to just kind of go over a couple of little random junk box gadgets and gizmos, things that kind of help fill out your bench. So this is a dual relay board, so you can control relatively large signals with this. You just give it 5 volts and ground, and then you send logic 1s or 0s to a couple of these pins, and the relays will click on and off. And they're you can't really see, but it has like the terminals to hook up wires to. We're going to use one of these that has 4 relays to spin our rotators left, right, and up and down. But this is just a little 2 relay board. These are like $3 or $4. Really nice if you want to like turn a lamp on or off, something kind of higher volume, higher current draw. Keeps things safer rather than trying to switch like big electronics with one of these tiny little boards, because these all use low level, basically TTL signals or lower. So these are really cool. This is an Arduino Pro Mini. So if you compare this to like a Uno board, these have the exact same processing power. This is just, it comes with pins, but I don't have any soldered in, and it's smaller, and it's meant to be used in a hardwired circuit. So after you prototype with one of these and you have your circuit all set up, you can then make it a lot smaller and put it on a Pro Mini. There's no USB on this, so you have to program it with a serial to USB adapter. And then it'll do the same thing as like one of the larger boards, for the most part. It has, I believe, the same number of IOs. They're just really jammed in there. Bunch of tiny little pins, but you can solder up, and I've made many circuits and gadgets with these. You can get them at different speeds and voltages to match your circuit. You can get a 3.3 volt one or a 5 volt, different clock speeds. You don't always want a fast one because the fast ones soak up more DC power. So if you want something that runs off of a battery for a long time and you're running simple code, you may not want a 20 megahertz one. You may want to get like a 2 megahertz one or something like that. So Pro Minis, they start at like $3 in single quantities, and you can get like a 5-pack for $10. They go down in volume. So definitely, if you want to make like permanent circuits, these are super awesome. So you can prototype, get it done, and then move it over to that and put it all in a nice tiny box, which is really nice and useful. And right next to it here, this is the USB to serial adapter that you would use to program it. So you don't have a USB port on this full time. Fortunately, the pinouts for the USB are standardized, relatively, at least between manufacturers. These were made by the same company. So what you can do is you just take it and you just shove it in there, basically, and all those 6 pins make contact, and then you program it, and then you pull this out, use it for something else, and you don't have the cost and the energy drain of a USB to serial running on this full time. You just use it to program there, flash your program, pull it out, and this thing is flashed and ready to use in whatever permanent application you want. So that's really useful. So get a USB to serial adapter. The brand doesn't matter. You can use FTDI or whatever you want, really. Doesn't matter all that much. These are pretty straightforward, and generally all of them work. And then you just stick it in their program, done, and then stick that back in the parts box. What other cool toys do we have? This is cute. It's not a digital thing. This is just a little 1-watt audio amp. You just hook it up to a speaker here with two terminals, and then give it a line input on the other ones. Pin's a little bent there. A little volume knob on it. This is cool if you want to make a little sound making gadget, or a little portable speaker or something like that. That'll drive like a small speaker to a pretty decent volume. These are cool because these are basically the same thing. They're tiny little audio amps. These are actually stereo. and you have to solder wires to them. And you know, my hard drive's filling up. I want to make sure that I'm not completely blasting out my storage. 984 megs. Hang on, I gotta delete some shit real quick because I want to make sure to get the whole recording here. Let me find some big files. Put that over on my NAS. I'll free up 9 gigs. I have a 240 gig hard drive in this. It's SSD, but it's a 240 hard drive, and it's, yeah, I have like 900 megs free. So I need to go buy like a big 1 terabyte or something. Anyways, these are Class D digital audio amps. This is a new style of amp that has just been kind of designed and sort of refined in the last 10 years or so. Doesn't use like analog amplification. It's actually a digital amplifier. Basically works at like 250 kilohertz, way above the limits of human hearing, and just turns the output on and off, kind of like that PWM stuff that we were talking about earlier, to make a very efficient amplifier. So these tiny little boards can actually do about 3 watts of output stereo. You notice there's no heatsink or anything, which normally you would have a heatsink on an amp that big, but these are like 90 to 95% efficient. So they're really cool. All my anime is on the NAS, and it really is too. But it's just like old 90s shit. Like basically, I have the 2002 through 2006, the entire like playlist of every night of Adult Swim. I don't watch anything new. I really don't. Cool gadget. This is what's called an ESP8266 board. That is actually Wi-Fi. This is a tiny Wi-Fi interface. You can program it with what SSID and key you want it to connect to, and then how you get data in and out of this is you just telnet to a port on it, and it will basically connect a couple of these pins, which are serial in and out, to that telnet port. So if I wanted to hook this up and like control it remotely, over Wi-Fi, I could, make a project that outputs the like bearing stuff here via telnet. I could just use this board, hook it up, and then program it. There's a little couple commands to set the SSID and all that, and then it would connect to my Wi-Fi, 2.4 gig, and then I could telnet to this thing on whatever IP it gets, and I have a link between the serial port on the pins and then the actual telnet port. So tiny little chip on there. Only has a couple milliwatts output, but it's fine for like inside a house. So that's the ESP8266 board. These are like, I don't know, $3 or $4, not too much. But I got one of those. A lot of fun to play with. Let's see what else we got. These are a different type of radio. These are, this is just a transmitter and a receiver, so it's one way. But it does send binary, whatever serial data you want over it, or just on-off signals. And it operates in the 433 megahertz band, which if you know anything about like garage door openers and stuff like that, it's just like there's just a little unlicensed radio band where they can use super low power gadgets like this without needing like FCC approval or anything like that. So these operate on 433. You can tune the frequency. So if you have multiple pairs of these set up, you can set each one to a different frequency. They're very, I guess, basically dumb devices. They don't have much intelligence. You don't set ports or IPs or anything. You just plug them in and start squirting ones and zeros into the pins of the transmitter, and then you will get ones and zeros on one of the pins of the receiver. It's really cool little things. And check on our force of gravity here. Holding steady. Gravity is not changing. That's good to know. So, yeah, I have all kinds of boxes of just little gadgets and random crap around here that I've collected. It's nice to just, kind of throw 30 or 40 bucks at the Chinese eBay vendors and just have them send you a grip of this shit all at once and stock up the bench. But yeah, you need breadboards, you need a bunch of jumper wires, input and output devices, various LCDs and stuff. I was at Micro Center earlier and I was shopping for like the little OLED panels and stuff like that. They didn't have any in stock, but I'm going to get some of those in because they're way fancier than the old school 20x4 LCDs, which I'm really good at programming. I know the tricks of these. You can actually load custom fonts into these, and special characters and all that stuff, so you can draw kind of weird primitive graphics, sort of like old school ASCII art. Scryad was pretty good. Yeah. Let's see, what other neat stuff do we have? I kind of want to mess with this thing. A little 8x8. Let's see if we can find a library for it. Lots of just kind of vague Google searching to figure out what you need to do for stuff like this. LED. Arduino. There we go. Yeah, Twitch plays Google. Hey, look, I've already clicked on this. Okay, this one actually addresses all of the individual pins on here. So this is actually socketed. So if you see there, it's got a bunch of pins on the back, and there's a couple of rows of headers on this. This is an adapter to change that into a serial bus, because you don't want to hook up 20 wires to make this work, or 16 at least. So let's find one that supports SPI, I believe. Yeah, Max 7219, I believe, is the chip on here. Da, 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 da. Just scroll through this, see if it does what we want. Yeah. Let's dump this into a sketch and see if we can get it to work. Yeah, you got to get the adapter to run this stuff off of serial buses. Like the 4x20 here, it normally has what's called a 4-bit interface. So it needs power, ground, a clock signal, and then 4 data lines. That's actually what I used for the vape back in the day. So I had 7 lines tied up just for the display. And the vape used an Uno, and I actually used up every single pin on that, and kind of doubled up with a couple of them. So, all right, just copy this dude's code, and we're gonna see if this works. Make a new sketch. All right. Did he put a loop in there? Okay, so this is everything. So we need to define what pins we're going to hook this up to, and then also hook it up to some pins. So let's see if we can debug or reverse engineer. If you're only using one, then use the function max single. Okay. All right. So let's take our accelerometer board, set it aside. Let's load up the other one. Let's hook some wires up. How is he defining the pins? Is it data in? Yeah. So on the back of these, it's kind of hard to read, but we have power, ground, and then data in, CS, I'm not sure what that is, and then the clock. Alright, so get some jumpers here, and for this we need male to females. I think I need 5. Let's pull 5 off. Alright. And then ground is going to be brown. Plus volts will be red. Those color codes, right? So let's knock those two out. Put this on the 5 volts. And then a ground. Yep. Get back in there. Okay. And then it just uses what? 2 for data. Pin 2. That'll be orange. Put the orange on digital pin 2. CS and clock are on 3 and 4. Yellow and green, respectively. Okay. Set it up so that we can see things there. Alright. So let's go through his code and let's see what the heck he's doing here. So we're going to use the max single function here. Okay, he's got the other 2 commented out. So I think this should work if we just plug it in and load the program. Yeah, they're all on by default. So let's see if this compiles. 8-byte. Compile? Are you gonna work? Please? Awesome. Alright. Let's load it up and see what this thing does. Yay. It drew a diagonal line. And then if you're doing one, it should look like this. Interesting. So let's look at that max single function and see what it does here. Oh, okay. So it's writing bytes. so it's flipping each bit. So let's see. Let's hack it a little bit. 3, 4, 5, 6, 7, 8. Now I think what we're gonna get instead is binary 1 through 8 on here. Let's find out. Neat. So yeah, we got 1, 2, 3, 4, 5, 6, 7, 8. Nifty. So that's how that works. I messed with these a long time ago, and I forgot how they address. It's actually flipped left to right, but not that big of a thing. That's awesome. Okay. So let's animate this a little bit. Let's make it more exciting. Let's see. Yeah, you see, it just turns on different bits. So you just read a 0 to 255, and it'll turn on whatever bits in that field. Q equals 1. Sorry, I haven't written a C4 in a long time. Q 8 Q plus plus. Oh, automatically puts it in there. Nice. And then we want another one in there. Yeah, I think I want 2 loops here. T equals 1. T plus plus. Cool. So then we can do a max single. QP, and then a delay 10. And then let's comment this out. How do you do it? Yeah. Relearning C live. So does that look sane? So it should count up 1 to 255 on each line, go through. Let's check my syntax. Oh. Can I just do an int? I think so. Hell yeah! Program master. Alright, let's see what it does here. Oh yeah. Badass. Filling up all the way. Yay, I'm so happy. That's too cool. And then it starts all over. Yeah. Yeah, it is pretty nice that this does a little bit of sanity checking for you. Steal this. Put it down here. And we don't need the inner loop. Q0. There we go. So this should clear the screen, I think, after we're done. Let's find out. It's hardware. It's programming. It's hardware and it's programming. what's amazing is that I can hear it through my headphones. I'm not sure if the mic's picking it up, but I can hear the data. Like, it's just a whine, basically. Yeah, and then it shuts it off and starts all over again. So cool, yay. So yeah, something like this might be fun. Like if you wanted to do like a little, like the little bump and VU meter spectrum analyzer type thing. If you can get numbers into your controller that represent the volume of your bass and your lows and your mids and treble and all that stuff, and then you just write bytes to this to show the current basically height of that column. You could very much do something like that and have a little digital VU meter or something like that. Might be cool. Binary counting on Twitch. Excellent. Yeah, it's cranking them out, and this is only like 1% CPU load for this too. Even though it's doing that every like 10 milliseconds. There's virtually no load on the chip. It's still like 97% idle. These things are shockingly quick. Excellent. All right. So yeah, fun little homebrew project. This guy's code is not too bad. And I'm not going to go too deep into like trying to hand roll a bunch of C today because, like I said, I'm just getting back into all this stuff. So I don't want to embarrass myself too hard. I successfully did a for loop. So that's pretty awesome. What might be cool? Trying to think of a way that I could use this in the rotator controller. Maybe figure out how to draw a line that rotates around or something like that. Right, the actual chip that this plugs into just wants bytes. Yes. So you just send it a like what line. It just has eight different bytes that you can address for the rows, and then you put 0 through 255 in there. Yeah, I'd have to figure out how to like do like sines and cosines and stuff to figure out the angle of something, and then figure out what lights to light up to draw that. But yeah, that's super cool. Sorry, it's kind of mesmerizing. It looks really good here. I know the camera kind of washes it out, but ones and zeros. That's all it is. Just a bunch of little freaking ones and zeros. That was fun. Neat. So this is a different type of serial bus than, say, the accelerometer and stuff like that. This is what's called SPI, and the other one uses a different protocol called I2C. Fortunately, there are libraries for both, so they're not compatible, but they're pretty much interchangeable. If this was a I2C backpack, they call them. That's what the chip is on the back. It's called a backpack. Much like the LCD on the accelerometer, that's got a little backpack on it that converts the serial data into a parallel. Super cool. So yeah, I'm having fun. This is good times. I'm trying to think of an easy way to draw lines on this thing. I mean, you can obviously just 255 things, but how do you figure out how to do an angle? I may mess with that off camera and see. Yeah, exactly. We would have to get a mathematical concept of something, like a line that's being drawn through an angle, and then you get 8 bits horizontal and 8 bytes vertical, and you'd have to map that on, and then you load up, like do an array probably of like 8 bytes, and then each one has a different byte value in it that represents what pixels are turned on there. So yeah, I might do that. That sounds really fun, actually. I've seen like advanced stuff. I had code years and years ago that would actually do scrolly text on this. It would like somebody did all the hard work of figuring out how to encode all like letters. Matter of fact, I want to see. I want to see if we can dig something up like that. Do more Googling. As long as y'all are having fun, I'm having fun. Scroll text. Let's see if somebody's done one. Oh, I did mean 8x8 LED. Here we go. I don't care about Android control via Bluetooth. I don't want the thing to get fucking rootkitted. But we will take a look here and see. Okay. All right. Yeah, see, this person's done. Ooh, they have smileys. Fancy. Yeah. New sketch. I want to try to draw a smiley face. This is completely different implementation. Let's see. Do we have that max matrix? No, we need it. Where is it? You better link to it up here. Yay. Thanks, GitHub. Alright. Yep, that's what I want. Dump it over in my libs. Administrator positions. Because Arduino sucks and they put everything in program files. Let's see if it sees it now. Badass. Okay, cool. So now, let's see what this thing does. So we set these to 2, 3, and 4, because that's what we're using. Dude, I'll take program files over fucking ham radio software. They all just install their themselves on the root of the C drive. Like they just make a folder and install it because they're all stuck in 1993 code land. So okay, so this just does a little automated scrolly program, does some stuff. Let's see what it does. You gonna do something? Is there like a huge delay or something? Maybe it doesn't like this. What is max in use? Yeah, I thought well they have it on different pins, but I just changed the assignment in here. but this is a different library. It's turning things all on and off. Okay, max in use is how many you got. Yeah, cause you can daisy chain these. One neat thing is on the back, the 5 pins on the left are duplicated on the right. So if you want, and they're spaced so that you can use a little, like the little motherboard jumpers, that we used to use back in the day. You can solder pins onto both sides and then have a bunch of these just side by side and use jumpers to connect them all, and you can have a big old wide display, or a tall one if you have it set up like that. This is the one we want here. Okay. Before we do that, I want to see. Clock is green. That's on 5. Oh wait. No. 0, 1, 2, 3, 4. Okay, yeah, I did it right. Weird. Well, I wonder why that one's not working right. Data in CS clock. Max in use. Let's try reset. Let's set that intensity. Let's turn that thing all the way up. Oh wait, we had a... What are these, just warnings? Why is it shitting out a bunch of stuff? Oh, it's doing a bunch of autocast from int to chars. Char? What do you think? The default, it looks like it's gonna draw a couple things with a 1-second delay. The letter A, the letter B, and then a couple of smileys. And then it's going to basically wipe the screen off with this little screen wipe thing, and then clear it out, and then loop over again. But the only thing I'm seeing is it just turn on all the way. Weird. So, like, those are just warnings, I guess? Something like that. I could throw debugs into the serial console, yeah. That's a thought. Let's see, do I have this? Program space.h. Yeah, I know. I don't want to clog it up too much with stuff. Let's see if the Instructables one is better. Yeah, see, that's how it looks if you want to chain these. Load that thing up. Sure, create that folder, move inside, and continue. All right. Does this compile? Let's see if it compiles. I saw a bunch of those fucking errors. Fewer ones. Warning, iteration 79 invokes undefined behavior. Aggressive loop. Oh shit, it's fun rolling loops. Let's try it though. So these are all letters. And yeah, see here are the bytes that it uses. Fun roll those fucking loops. Ooh, mem copies. This is all kinds of wacky shit. The stock Arduinos just use C. There are ones that you can write Python on, ones that you can write even Node on. But it's not the strict Arduino platform. Arduino is a combination of a hardware spec. It's open spec, so anybody can build boards, which is why I got my clone boards. And the language. So anything else is kind of additional layers and wrappers that other companies write, and they'll have a different IDE and stuff. And oh yeah, you're right. ITHC. Yeah, I think there's one that runs Java too. At that point, you're kind of talking about having a slightly different microcontroller, really. But it's the same concept. You have a little board that has digital IOs and so on and so forth. And you control those with your program, and yeah, it'll do the same thing, but just kind of a different environment. Oh yeah, right. We didn't reset the pins on this. Should be 2, 3, and 4. 2, 3, 4. All right. Let's see what we got here. Upload. Oh yeah. Hang on. Nice. Hell yeah. This one worked great. Okay, so now I give Reddit the clicks because the more Reddit gets clicked, the more money I make. Will this fit? Low memory. Stability problems may occur. Well, of course, you're a veteran. Okay, let's do a nice reset here. Oh, yeah. I want a giant one of these for the back window of my car. The font's pretty nice, isn't it? It looks really good here. Like, again, it's kind of blowing out the camera, but it looks really, really nice in person. And it's totally, like, readable. 300 confirmed kills. Yeah, let me back it off and see here. Let's see if we can get it a little bit more. Ooh, it's only on 4. Let's try 2. Yeah, it's just kind of. It's because the overhead light. That's the actual problem. I wish I had like. Oh wait, but I do. All right, let's try this. Eh, eh. Reset. That's pretty good. Yeah, a lot of webcams do not like emissive light sources. I guess they're called. All right, so I now have the library to shit out arbitrary text. Um, that's exciting. That's super cool. I want to get like a bunch more of these and make a big long display now. That's awesome. It's so like calming to have it just like slowly scroll across. Um, I'm seeing here. The number is message speed. Okay. Um, okay. No, it's inverse. That's the delay, I think. Oh yeah. There we go. I'd put the Tom Collins post, but I know it doesn't fit in the memory. Oh, I love this little device. I'm glad I decided to fuck with this one a little bit. Oh, wow. We've got Navy SEAL hardware on demand. It's actually easier to read on the camera at this point. Yeah, do Game of Life. That would be an excellent project. Um, yeah, it'd be a really good challenge. Like, I guess all you'd have to do is you inside your loop or even outside, you can have a couple functions that take a particular like you're gonna have to have actual memory stored and you're gonna draw the screen off of that. So you're gonna like build up a frame buffer basically. With each cell, and then you need to go figure out the game of life rules and then just write functions to um I guess, access each cell in the matrix, see if it's a 1 or a 0, and then evaluate everything around it, and then set those bytes, and then iterate through or something like that. So you might need to have like 2 frame buffers for current frame and next frame, and then you build it up in the next frame, because otherwise you get like a weird recursion type thing. But yeah, that would be a really fun project. If you get Game of Life running on one of these, I will totally feature it on the stream. I mean, you can Google Hangouts in if you want, but if you just want to show off your code, I will totally feature it here. It's still going. And we sped it up by a factor of 3, and it's still going. Yay, we got all the way through. Amazing. Oh, too good. Too good. All right. All right, team. Well, like I mentioned earlier, this is probably just going to be a 2-hour show. I'm so tired, and that took the remaining energy out of me. So I'm going to do a little rest and recuperation. So we're going to cut it an hour short today. So I'm sorry for that, but self-care is important. So I'm going to relax and power up, but fear not, because this has been our first 3-night week for the stream, so we're going to continue doing it, because I liked hopping on Mondays too. So we'll be doing Monday nights, Wednesday nights, and Saturday afternoons now. Yeah, the next session is just a couple days away. I'm going to start working on the rotator controller some more. Hopefully have a nice little prototype board set up then. And then we'll dive right into that. And then if you guys are having fun with this, we may do a half hour to an hour of each stream, and kind of focus on the Arduino and the prototyping stuff like that. If you're having fun with it, we will continue on, and I'll just do dumb shit on the side. We'll just keep that as a little side feature. So thanks everybody for tuning in. I'm going to call it, go pet a cat, eat a slice of pizza, and we will see you Monday at 7 p.m. Mountain. That is 0200 UTC Tuesday. So if you don't know time zones and UTC conversions, figure it out, because you're going to need them for the show. So again, sincerely, thank you very much, everybody, for hopping on. This is a lot of fun, and we will continue it in just a couple of days. Till then, the MATTYZCAST is signing off, and wish everybody a wonderful weekend. Go have fun.